Hello, I'm Mr. Vanderweist. I'm sure you already know that, but since I was making videos for you last spring when you were in algebra and I had the big beard, maybe you didn't recognize me now, so I thought I'd reintroduce myself. I'm still the same guy. But now it's geometry. So, the first lesson of the year is going to be pretty simple. It's mostly going to be definitions of these right here. All right, and because it's fairly simple and because we have 7 tests to do in 7 weeks, I'm going to give you this first test on Thursday of week 1. So we're jumping right in here. Day 1. We got to get started and keep moving, or else we're going to run out of time, or we're going to get to the end of the quarter and we're not going to have any time to review for the benchmark. And that's a big pet peeve of mine. I love to have a few days at the end of the quarter to review for the benchmark so that you guys can all do as good as possible on the benchmark. All right, so for today, we're going to focus on these first 4. Tomorrow, we'll talk about planes. And then Wednesday, we'll talk about circles and angles and how all these fit into 0 to 3 dimensions. All right, and then Thursday, we'll take the test. So let's get right to it. A point. The reason that we're starting with just a point and that we're starting with these lines and rays and segments is that they're building blocks for geometry. You can't draw anything, you can't build anything without these basic building blocks, and that's how geometry got started thousands of years ago, was from a point and a line, and that just everything got created from there. And it's actually a book called Euclid's Elements you can look up, and it explains all this stuff. But regardless, a point, what you really need to know about a point is that it has 0 dimensions. All right, that may be a little bit surprising to some people that there is such thing as 0 dimensions, and there is. It's a point. It's the only thing that has 0 dimensions. It doesn't have length or width. And then these next 3, I kind of grouped them together because they're all very similar. They all have 1 dimension. All right, they just have length. They don't have width, they don't have height, they just have a length. They just go on in one direction. So those are your basic dimensions there. And like I said, we'll get to 2 and 3 dimensions tomorrow, and on Wednesday, the shapes that have those types of dimensions. But for now, we're dealing with 0 and 1 dimensions today. And I'm going to erase this, and I'm going to give you the definitions for line, segment, and ray. All 3 of those things, lines, segments, and rays, are made up of points in a row. So there are just an infinite amount of points if it's a line. So a line, let's start with a line. A line has 0 endpoints. 0 endpoints. That means it doesn't end. There's no end to a line. A line goes on forever in each direction. So a line is designated by this symbol right here. Those arrows means that that line is going to go on to the right forever, and it's going to go on to the left forever. That line is just going to keep on going forever. So there's an infinite amount of points that make up that line. All right. Now you have a ray. A ray has 1 endpoint. So it goes on forever just in one direction. So if it doesn't go on forever in the other direction, it's designated by a big point, a big dot. So that's kind of like that's called an endpoint. It's kind of like your stopping or your starting point. And then it'll go on in one direction forever. So it looks like that. So it only has an arrow on one end. And then you have a segment, and you can probably imagine what's coming up next here. A segment has 2 endpoints. So it does not go on forever in either direction. It stops in both directions. So it has a big dot point on each end, no arrows. So that's your segment. So a segment is a finite length. A ray is infinitely long. Now this is a little bit tricky to understand, this concept, how a ray can be infinitely long and a line can be infinitely long, but yet a line you would think would be bigger because it goes on forever in both directions, but a ray only goes on forever in one direction. But forever in one direction is forever. So it's going to keep on going and going and going. So it's going to be infinitely long, just like a line. So that's a little confusing. That's a deeper concept that you're really not going to be tested on to understand what infinity really means, because a lot of scientists don't even understand what infinity means. Infinity is kind of a mind-bending concept. But for the purpose of this test, this is what you need to know. A line has an arrow on each end, goes on forever in both directions. A ray has an arrow on only one end, goes on in one direction forever. And a way to kind of remember that is the sun. You could think of the sun up in the sky, and it's shining rays of light in every direction. The end point, or the point that does, is the sun itself, and then the rays are going on from the sun in one direction forever. So a ray is kind of like a ray of light coming from the sun. You could think of it also as, say, like a flashlight. So that's my flashlight, and the light emits from the flashlight in one direction and goes on forever, technically, or theoretically it goes on forever. You're not going to see a flashlight if you're miles and miles away, but regardless, you get my point. It starts from one point and goes in one direction. A flashlight doesn't shine backwards and forwards, it just shines in one direction. So a ray is like a ray of light that has a starting point. And then a segment is just a piece of a line. If you have a line and you just want to take a chunk out of that line, say you want to just deal with this part of the line, then you're dealing with a segment of that line, a section of that line, and that's a segment. So that's your basic definitions for line, ray, and segment, and they all have one dimension. So those are the things that you need to know, the basics that you need to know for those three terms. Now, later in the week, we're going to use those three, what would I call them? I don't want to call them three lines, because there's only one of them is technically a line. The other ones are segment and rays. But those three one-dimensional figures, we're going to use those, we're going to combine two of them together to make angles. And I'll show you, everybody thinks they know what an angle is, but there's a little bit more to an angle than what you probably already know. So we'll get into that, I think, on Wednesday. But for the homework tonight, for the work that you're supposed to do in the do section, that should about cover it right there. There's one thing that might come up. There's one last thing I want to show you here, and that's with a ray. Ray can be a little bit tricky. All right, a ray, let me just draw a basic ray here. You're going to, a lot of times they'll draw a ray and they'll just pick out a point on the ray like that, and we'll say this is point A and this is point B. Now that point doesn't really mean anything. The ray is going through that point off to the right forever. The only reason they picked out a point on there is so that they can name this ray. So you would call this ray AB, and you would draw the arrow like that. Okay, that means that the ray is starting at A. The first letter is your starting point, or initial point is what it's usually called, initial point. So the initial point is the starting point of your ray. And then the second letter, the B, is the one that it's going through and going towards B and beyond B forever in that direction. So you could have, say, another point up here, C, and you could draw a ray starting at A and going through C, and that would be ray AC. Now let's imagine you had a point that was on the same line, same trajectory as AB, and it's over here, and it's called D. You could have a ray called AD. It starts at A and it goes through D, so we'll call that ray AD. Now this is a little bit special, ray AD compared to ray AB. These are called opposite rays. So that is a term that will come up on the test, on your homework. It's something that you need to know. Opposite rays. Opposite rays are rays that go in exactly the opposite direction. So AB is a ray, AC is a ray. They both have the same initial point, but they're not opposite rays because they don't go in opposite directions. All right, AB is going straight across to the right, and AC is going up at an angle. It's not the opposite direction. It's kind of like when I was talking about the flashlight earlier. Your flashlight shines in one direction like this, it does not shine directly behind you. If it did shine directly behind you, that would be an opposite ray to the ray coming out of the front of the flashlight. So it's got to go exactly in the opposite direction. Now when you have a flashlight, it's not like you have one tiny little laser beam that comes out. The light actually goes out something like that. So it's shooting out more than one ray, but they're not opposite rays. Even though they're multiple rays, they're not opposite because they're not going in the opposite direction of each other. They're going in generally the same direction, just a little bit of a different angle. This would be the one that would be an opposite ray from the one going straight out from the flashlight. So that's the definition. That's what opposite ray means, is that they have to be going exactly in opposite directions. And that's why it matters what letter you pick first. Because let's go back to the beginning. Let's say I draw my ray AB, and I call this ray BA. It's 2 points on the ray, and I have the correct arrow there. I have an arrow, so it looks like a ray, so that should be good, right? No, that's not right. You can't do that. Because ray BA is actually this ray right here. That's ray BA. So ray BA is that. Ray AB is this. And if you combine them together, it makes a line. So you combine ray BA and ray AB together, and it makes a line. Now they're going in both directions forever, and that's a line. So you have to be careful with a ray. You have to be careful which letter you write down first. When it comes to a line and a segment, you don't have to be careful. So if we just have a segment AB, we call this segment AB, and that's just a line above it with no arrows because it's not going in either direction forever. That's the same thing as if you were to say segment BA. They have the same length. They have the same length, and they're not going in either direction forever. So segment AB and segment BA mean the exact same thing. You can write that down either way. Same with a line. If you have a line, all right, this is a line, but we have to name that line, so we're just going to pick 2 points on the line to name it after, and again, I'll use AB. So you could call this line AB, or you could call it line BA. Doesn't matter which one you use because they're going on in each direction forever. It's the same exact line. The only time it matters is with a ray. If you were to say if you have a question that says, is ray BA in this picture the same? Does it equal ray AB? The answer is no. Ray BA does not equal ray AB because ray BA starts at B and goes to the left. Ray AB starts at A and goes to the right. It's like two different flashlights. You have a flashlight at B shining to the left, and you have a flashlight at A shining to the right. They're not the same thing. However, the line AB and the line BA are the same, or the segment AB and the segment BA are the same. So that's what makes a ray a little bit tricky or a little bit different than a line and a segment, is that the order of the letters matter. So that's the lesson for day one. Welcome back to school 2021 version. I think you guys will like geometry. It's a little bit different than any math you've ever taken before. So some of you, unfortunately, probably won't like the geometry because it's not a lot of adding and subtracting and formulas like algebra is and like most of your math has been. It's a lot more pictures and intuitive thinking and logical thinking and building on your thinking. So I know some lawyers, some attorneys that weren't very good at math going through school, but they were excellent at geometry because you build logically on the argument before. So that's why we're starting with the basics. We're starting with points and lines, and we're going to build on that to build more shapes, and we'll get into proofs later in the year where you'll have to make logical arguments to prove things are true, kind of like an attorney does. So they're probably, I think that's enough for today. That's definitely enough to do the couple problems that are in your do section. It looks like there's only two problems in there, one and two, but problem two actually has like 6 parts to it. But it'll be quick. I didn't give you much for day one. So good luck with that. And if you have any questions, we'll be live every day for like 10 minutes, like you are in every class. You can ask me questions then. That's a great time to ask questions.